From the first instant, imagine an immense, dark cosmic cloud, cold and silent, slowly stirring. Gravity begins its pull, gently squeezing gas and dust together, awakening the earliest heartbeat of a future star. As gravity tightens its grip, the cloud collapses inward, forming a bright spinning core called a protostar, wrapped in glowing gas. Heat rises, the center blazes, but true starlight has not yet begun. Deep inside the protostar, temperatures climb to incredible levels. Suddenly, nuclear fusion ignites, turning hydrogen into helium. A new star is born, shining steadily, pushing outward against its own gravity. Time stretches across billions of years. In its main sequence stage, the star burns calmly, perfectly balanced. Gravity pulls inward while fusion pushes outward, creating a long era of stable, life-giving light. As hydrogen in the core runs low, balance breaks. The star swells into a giant, its outer layers ballooning outward. Its surface cools and reddens, while the core shrinks and heats, becoming unstable. The swollen star can no longer hold its outer layers. They drift away into space as a glowing shell of gas, while the hot core is left behind, a dense, brilliant remnant that still shines fiercely. What remains is a white dwarf, a tiny, incredibly dense star ember. No more fusion burns inside it. Slowly, over unimaginable ages, it cools and fades, releasing the last whispers of its stored heat. Across the universe, countless stars repeat this cycle. From silent clouds to brilliant suns to fading embers, each star writes a chapter in cosmic history, forging the elements that make worlds like ours.